So are you okay with your transformations? Make sure you put them in order that they happen. Go by the x first, start there, and work yourself out. So in this guy, the second one, you're starting with this guy inside, then you're doing the -4. Whether you do the reflection or the vertical stretch, doesn't matter which one comes first there. On Friday, we did number 4. So if you weren't here Friday, it would be a good thing to go to the Moodle, because this number 4 was nice because it really tied in the limits to your graph. We were able to see your point of discontinuity. We were able to see when it reached that limit. We were able to look at your infinities because they came out here to the 0. Same thing where my horizontal asymptote was. So your horizontal asymptote rules and your infinity rules are exactly the same. And you have to know those 3 rules. Okay, we did that Friday. This was another one. Anybody struggle with this one at all? Everybody do these? Yeah. At least if you did 4 and not 5, you did one of them at least, because this works the same way. This one, we could not factor and reduce. There was nothing to factor your numerator in that would reduce anything. So therefore, the zeros of the denominator are your vertical asymptotes. It's also where your domain restriction is. Your denominator cannot be 0. So do your domain with that as well. Find your vertical asymptote. See your vertical asymptote? That's it. That's going to cause your end behaviors. That's going to mean as my limit of x approaches -5, I have no limit. Limit does not exist. This is not removable, right? Because now we can see what it's doing to your end behaviors. It's causing them to go off in different directions. Where before we just looked at an end behavior, now we just called it a limit. Your mins and maxes, this was a good one for mins and maxes. Remember absolute versus relative. An absolute means that is absolutely the highest you can be, such as this. This is an absolute max. Absolutely the highest point. A relative one says, well, it's a max for this area relative to that spot. But I have no max for this kind of graph, because my max just keeps on going up and up. My min keeps on going down and down. This guy, the second one would be a relative. This would be an absolute. Do that part on your calculator. Second calc, number 4 max, number 3 min, something like that. And bring your cursor to the left, bring your cursor to the right, and then guess. Everybody good with that one? No? Okay. I'm actually going to break one apart probably tomorrow and do the whole thing tomorrow. I'm going to bring a different one in if we don't have one in here. Point of discontinuities, we had none because there were nothing that was factorable and removable. And you could actually look for your horizontal asymptote. A horizontal asymptote says, my numerator is greater than my denominator. I do not have a horizontal asymptote. My limit does not exist, and we can see your limit not existing, right? However, if it's one more than the numerator, I have a slant. I could possibly have a slant asymptote. God bless you. And I don't think I found your slant asymptote. So remember, your slant asymptote, you're going to divide. This one probably has a slant that goes this way. Anybody remember how to do a slant asymptote? When your numerator is exactly one more than your denominator, we did a synthetic division. Remember your synthetic division? It's coming back. So here's my slant. I pull this out. Yep. 1, -4, 2. And I divide by, I set this equal to 0. I divide by -5. Synthetic division. Bring the 1 down. 1 times a -5. Bring this down, -9. And this is 45. I don't care about my remainder on this. All I care about is this. Swap the x. 1x minus 9. There's going to be my slant asymptote. And you can throw that in your y equals as well to see that it will be a slant. I think there are other slant ones on here that asked you just slant. Standard form, we did these. Does anybody have any questions on these? I think we did A and C. So let me get to B. Anybody have any questions on B? Aaron? Oh, say that again. How do you set it up? If you're going to complete the square, we notice that they're both pluses and their coefficients are different. So we know we have an ellipse. If they're both pluses and their coefficients are different, ellipse. If they're both pluses and their coefficients are the same, circle. If one's a minus, hyperbola. If only one square, parabola. So on Friday we did a parabola and I think we did a hyperbola. This was the ellipse. You want to group these together. You want to group your x's, you want to group your y's. And then you're going to complete the square for both of them. Remember, your coefficient has to be a 1. So we factored out the 4 and we left the space. Then we said half of -2 is -1. 1 squared is 1. Then we had to distribute this back out to bring it to the other side. Remember, complete the square? For the second part, the y coefficient is 1. So half of 4 is 2. 2 squared is 4. And nothing to bring that over, we just put that over there. Combine everything on the right-hand side and make sure that's equal to 1. So divide everything by that 16. These should divide out. And this is an ellipse. The larger one is the major one on an ellipse. Because the y is going to be the oval. So that's the major. That's the a squared, that's the b squared. After you completed this, you had to tell all the parts to it. So A, B, and C are important. The distance from A is the distance from your center to your vertex. B, from your center to your co-vertex. And C, from your center to your foci. So start with your center. Remember, it comes out the opposite way. And then work your way there. This is a translated axis. Vertex, co-vertex, foci. In the ellipse, we subtract a squared minus b squared. In the hyperbola, we add because we want to come outside of it. The only real big difference, we create the oval in this. We create a rectangle for the hyperbola because we wanted little parabolas to come out of there. You know you're going to see one of these. Yes. The A is the larger number on the bottom. Because in an add, it doesn't matter who comes first. But what matters is which one is the largest. Actually, if you didn't even know the A or the B, you start like this, watch. Pull out your center, 1, -2. Then off your Y, go up 4, down 4. Off your X, go over 2, over 2. Which one is the longer one? This one's 4, this one's 2. So it would be the Y, right? So that's the A. The A is the longer one. The B is the shorter one, and the C, subtract them. You want to be inside your list. So funny. Yes?
How do you find CV stand for again?
The C,
CV.
CV, oh, covert vertice.
How do you find that?
The covertice, so keep your center in the middle at -1, 2. The covertice is this guy right here, is take B, 2, and add 2. This time your X is moving. Add 2 to this side. So my center was 1, -2. Add 2 to this, so it becomes 3, -2. And then subtract 2. it becomes -1, -2. Your covertices on your minor axis. Whichever one is the longer axis is your major. That's the plus or minus A. Whatever one's on your minor axis, that's the plus or minus B. And the C is off your major axis, plus or minus C. Try to get a better grip from graphing than from memorizing the formulas. Good? We did the hyperbola. This was nice, and you're going to see one of these. I can tell you now, you're going to see one of these. All you have to do is graph this. It's a parametric. How do I know, even without me telling you a parametric, how do I know it's parametric? T. Good. So you're going to set your mode to parametric. Be careful. Set your angle. If you're going to put degrees in here, set your angle to degrees. Make sure your mode says degrees. In these guys, I think it's easier to solve them algebraically if you don't spot it. Remember how we said we had to solve for the angle? So divide both sides by 4. So x over 4 equals the cosine of 2t. Then we did that for the sine. If then you use this, you get to see the ellipse. So that you, I think algebraically, you see the ellipse before you do on the parametric in case your parametric is off. But I'm going to have you identify this and identify the graph of it. I thought that was a pretty easy question. I left it as a multiple choice, find the graph of that. So if you're looking at your parametrics, you can always solve it algebraically to get there as well. And then we did your things here. Let me ask you, as we go through this, keep in mind in case you find more formulas. So again, this was saying 8 years compounded annually. Put the 1 in there. Money, 2 decimals. Compounded quarterly. Your N is 4. Be careful of your rate, guys. Your rate, make sure it's a decimal. Move this 2 positions over, 2 decimal places over. Daily, 365. Monthly, 12. Per is your continuously. It has its own formula. Okay. We did this one. Some of your trig functions. You can use your reciprocal. And we kind of set up part B. Take the square root. Whenever you take the square root, you get a plus or minus. Remember that. So you had all 4 quadrants. Remember your special right triangles. These don't go away. 1, 2, radical 3. And the other one is the 45, 45. 1, 1, radical 2. It's the only 2 I'm going to ask you. Besides your quadrant angles. Remember your quadrant angles. Whenever you see the sine or the cosine as 1 or 0, it's a quadrangle. Okay, so whatever your reference angle is, divide that by 180.
So you had to find a reference angle first.
Yeah, you had to find your reference angle. You had to know that this was your special triangle, so opposite the 1 is your 30. So take 30 divided by 180 divided by 30, that's your 6. Therefore, your angle is pi over 6. Now, this is pi, this is 2 pi. So now to convert this to sixes, just make it the same, 6 over 6. If I want thirds, 3 over 3. If I want fourths, 4 over 4. Because this one has to cancel out the pi. This one has to double it. So double this one, 12 pi over 6. It makes it easier for you to name your angle. This one is the 1 pi, 1 less than this is 5 pi, 1 more than 6 is 7 pi, and 1 less than 12 is 11 pi. You can actually find all your angles in degrees and convert them to radians. Whatever I give you this in, your domain is what you have to give me your answer in. If I give it to you in degrees, leave it in degrees. I give it to you in radians, give it to me in radians. Okay? Yes? Chris?
Tangent is sine over cosine, right?
Sine over cosine, y over x. I think that was it for this one. We did 2, so let's go to 3. Did we do this one for 3 in here? Yes. Kyle? We did the first one. This is important that you get the inequality for a quadratic. Get everything to one side, factor it, find your critical values. This is what's important right here. I want the positives in this case. If it's negative, means less than or equal to, is a negative. The equal to sign means they're filled in. That's a hard bracket. Without the equal sign, soft bracket. Now remember, you could graph this in your y equal. You could look for a value to the left of -4. You could look for a value in the middle. You could look for a value to the right of that. Is my y positive? Is my y negative? So we do positive y, negative y, positive y. You could realize this is a parabola. You just found your roots where they cross the x-axis. Your parabola has to open up. So I think it's easier just to use that part of it. Since it's going to be quadratic, then you can find your positives are above the line, your negatives are below the line. So if I had less than or equal to, then you'd have an and that fell right in between here, if I wanted the negative part of it. That's important, and I'll tell you why, because everybody forgets about their poor little quadratics. Like in this one here, you have to find me your domain restriction. There's 3 domain restrictions. 1 is 0 in the denominator. 2, no negative under a radical. And 3, a radical under in a denominator cannot also have a 0. So you're going to set, this is underneath, so you have to set this greater than 0. You have to set whatever's in there greater than 0 to find your domain. You could also graph that. If you graph that in your calculator, you would see a little graph of that as well. You're going to see this little piece go like this. You might have to change your window because you won't be able to see the end of it, but at least you'll see the opening up part. So this again, you're going to graph this. So you're going to do plus or minus 25. You cannot use the 0 in here, so I cannot put 25 in here. So they say open. This parabola, which way does that open? Up or down? With a negative in front of the x squared. Down. So it's going like this. You want this to be positives. So here's your positive above the line. You want this piece right in here. And if this is a multiple choice, you can always test your answers. I do have some multiple choice in there. I want your work. But I put the multiple choice out there sometimes to like kind of help you decide how does she want me to answer this thing. What is she looking for? So sometimes you can work yourself backwards. If you're seeing that these are 25s, maybe the square root of 625 is 25. That kind of helps you start. If I've got my 25s as my endpoints, either they're less than, greater than, in between, I can make a number line with 25s in here. And it'll help you see which way to go. Do you know what I'm saying with that multiple choice? I think it's just a little helpful. And it's been a while since we did these. Okay, here's your slant. Here's your slant asymptote. When the numerator is 1 more than the denominator, we have a slant. We have no horizontals. Aaron, put your phone away. We have no horizontals, but we have a slant. So we take this factor out, we pull out your coefficients, and we divide synthetically. Bring down the first one, multiply, add them together, multiply, Now, when you add this up, we don't care about your remainder. This is your remainder. All we care about is y equals, and since it's one more, it's got to have an x value, just plop an x right in there. There's your asymptote. So you could graph this, and in the second line, graph your asymptote. It'll help. You know you're going to see one of these. These are good for synthetic division. It's what helps your end behavior right along that asymptote. It's usually something, when your asymptote goes like this, you usually see these in here. These graphs. They go like that. This guides your end behavior. It's usually what you see. Questions? Stop me if you have any questions, guys. The range is a little trickier because number one, you have to find your domain. You have to take a look at the graph because from that you can find your range. So I can tell if I'm going to factor, if I'm going to reduce anything, I have a point of discontinuity. If not, I have a vertical asymptote. This is my vertical asymptote. Horizontal asymptote, I'll give you your three rules. When they're the same, top and bottom, numerator, denominator, you take the coefficients. This is your asymptote. You can't use that y value. So you wouldn't know that until you graphed it. So therefore, your range says, and there's no point of discontinuity to take out. Your range says, from the bottom, come up from negative infinity, whoops, stop at the 1/2. Don't go any further. From 1/2, keep on going. The range means you have to find your domain. You have to look at your sketch. Range is always a little trickier. Good? Which of the following is correct for this graph? So I'm asking you for asymptotes and intercepts. Sometimes you can turn around and graph that guy, and you can pretty much spot where the asymptote is. You can even do an intercept and figure out that one, your y-intercept. You can figure out whatever your y-intercept is when x is 0, do a value for 0, figure out your y. And you should kind of spot your horizontal. You can see where your graph goes. I didn't give a graph of this, but I factored this, and the guy that we factor out is your point of discontinuity. Sometimes I might ask you, does it have a point of discontinuity? What is left is your vertical asymptote. So is my vertical asymptote when x is 2? Nope, my vertical asymptote was when x is 4. A nice way to do this, the same as you do on your SATs, go through each one. Put a check for an x. Don't do this part until the choices, until your x and your checks are there. So does it have a horizontal? When the numerator is the same as the denominator, I have a ratio. Yep, it has a horizontal. And if I want, I can put the x for 0 in here. Take this piece right here and put in x of 0, so you get -3 over -4, which gives you 3/4. There's my intercept. So I have two things that were true. Then go here and do which ones are true. Don't try to do them at the same time. Cross them off one at a time. We did a lot with rationals. We did a lot with your graphing. Find your limit. Now, first thing, try to plug the 3 in. The 3 makes your denominator have a 0. So either we have to factor and reduce it, we have to rationalize it, we have to do something else. So we try factoring. If we can reduce this, write what's left. And that's where your point of discontinuity is. That's when x is 3. When you substitute 3 back into this x right here, you get 3/5. That's the answer I'm looking for, not 3. That's why sometimes in multiple choices this is misleading, but I'm looking for the 3/5. You guys have no questions? You're doing good on this? Have you been doing your review? Okay. Which value does the limit not exist? Okay. Oh, I'm sorry. Does the limit exist? So it does not exist at B. It does not exist at A, but you see C? It approaches the same. It approaches this guy. So that limit, we could find that Y value. So it does exist at C. That's a question to watch, right? Usually we say where it does not exist. This is a good example for a relative maximum. This one right here is your relative max. Do a second calc. That. Bring it to the left, bring it to the right of this guy, and then guess the middle one. Remember to give me 3 decimals. Remember your value of your function is your y value. That's the value of that function. Everybody okay with this one? Nice bracket one. Let's see where we are. Here's your point of discontinuity, the point that I can factor out. So it has a point of discontinuity. Maybe tomorrow we'll start with 10 on this. Is that good? These are kind of closing up out there. All right.